Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel. This episode is brought to you by PCBWay. More about them a little bit later on. So I have no guest today. The reason for that is actually I've been reaching out to a couple of people to get onto the podcast, and there seems to be a lot of interest. It just didn't work out that we didn't set a date yet, and this podcast has to go out every 2 weeks, come rain or shine. And so you have to deal with me, which is fine because I've been doing a lot of stuff recently. So I've got a lot of stuff to say today. Now, the only problem is I still have that cough. So in a couple of weeks, in 2 weeks or so, it'll be like 2 months since I've been coughing. So that's not great. And I also have my sciatic nerve, which is hurting me. So sitting on this chair is not fantastic, but I will persevere for all the people who listen at home. You guys are my inspiration. All right. So the big thing is that last week I was off of work. So I came off of a really intensive contract with the college. So I was extremely busy. And then last week, there was not a lot of work at the mechanics job that I work. And there was no more college work to be done. So I had the week off, which was great. But that also meant I had a lot of time to do live streams. And live streams, if you're not aware, is where I do a lot of my work now. It's a little bit less isolating doing work on a live stream. I'll give you an example. So when I make a video, it often takes me like 2 hours of prep, whether that be like prototyping something or, putting something together or getting my thoughts combined or whatever. Typically, I would do that with a podcast playing in the background or maybe a TV show because I've been really liking Clarkson's Farm lately. I've been rewatching it. It's phenomenal. Well, at the end of those 2 hours, then I have to actually hit record and do the thing. So I have to sort of put into motion everything I've been prepping for 2 hours. If I hit a hitch, however, if I'm listening to a podcast or a TV show, I'll tend to just sit down. And when I sit down, then I'm just paying attention to the TV show. I procrastinate doing the recording and then it never gets done. Well, if I'm quote unquote stuck on the live stream with an audience listening, which has been getting more popular, by the way, which has been pretty nice. Link in the description if you want to check that out. Then all the troubles that I bump into when I'm making a video, you guys are there sharing in the moment. So I just have to put my head down and keep working at it until we get to a reasonable conclusion. So I've been getting a lot of videos recorded. And in fact, I took a look at my editing queue and it's pretty embarrassing. I've got a lot of videos that I have to edit up in the next couple of days. Let's say in the next week or so. Because in the next couple of days, it's my birthday. So I'm doing some stuff, hanging out with my wife. We're going to celebrate my birthday a little bit. So I probably won't be working on that. But by this weekend, I should have another live stream set up. So the best place to find me is on Blue Sky. If you follow me on Blue Sky or if you just check my channel community page, I usually post, 12 to 24 hours before I'm going to go live. So check out the notifications there. So yeah, I checked out my editing queue and I noticed that I still haven't edited the Fluke 8000A video. So I think this actually dates from last year. I picked up a used, I know because there was no snow on the ground when I picked it up, but I picked up a used Fluke 8000A multimeter, which is a benchtop unit, quite old. I don't remember what years it was produced in, but inside it had some NiCad batteries, which I believe the date code was 1985. So yeah, this thing is not super precise or anything, but it was really cool to give it a whirl. It also has a bunch of calibration stickers from Toronto and Montreal. Really has some history on there. But the thing is hilarious because it's completely rendered obsolete by a $20 Amazon multimeter these days. It's just really cool for the nostalgia, right? And to open it up and take a look inside. If you guys have any idea what I should do with that multimeter, I mean, it's still fairly precise. It still works, but I kind of have way too many multimeters already, and I don't really need this dinosaur. So if you have any idea what I can use it for, you let me know. I don't really want to destroy it. It still works. I can see if Makerspace wants it, but they probably don't. These things are, again, a regular like $20 multimeter beats the snot out of it. So yeah, I don't know. You guys let me know down in the comments if you have any ideas. So then on the subject of live streams, I've actually been doing projects again with microcontrollers, and I've decided to take a look at the RP2040. Now, I know I'm a bit late to the party. Everyone has, done the RP2040s. Now people are on to the RP2350s and et cetera, et cetera. But for me, I mean, it was a big step. Let me tell you my experience with the RP2040. I was sent 2 RP2040s. I think PCBWay sent them to me. I mean, they said they were going to send them for free, but they just used my points that I accumulated on their website. But anyways, doesn't matter. So they send them to me, and I go through the motions. You have to add the board definitions and stuff. It's not super easy, but it is easy. It's not hard, but you still have to look it up. What I've found is that I couldn't find the COM port. So I couldn't plug it into, I plugged it into USB and it wouldn't show up on my COM list. And this was at a time when it came out, when I was really quite busy. And so I Googled around and I just couldn't figure it out. People were using Python and stuff like that. And I thought, you know what, maybe it's just not for me. Maybe it's because I use the Arduino IDE. I prefer using the Arduino IDE. Maybe it was because I had counterfeit chips. I had no way of knowing. It just wouldn't work. So I shelved it for a while, and I've come back to it more recently, very recently, this month. And the reason I decided to use it is because I figured with all the RP2040 boards that are available out there for very inexpensive, and the 2350s, which are a lot more capable, I figure it's time that I take a look, see what all the fuss is about. And well, in the end, I like these boards. I mean, the RP2040 is a pretty awesome little chip. I think you get 30 GPIO, you get 12-bit analog inputs, you get all sorts of cool stuff. But as an Arduino IDE user, and let me know if I'm wrong about this, I just like the Arduino IDE. Some people just tell me to use whatever the Microsoft alternative, VS Code or whatever it is. But I like the Arduino IDE. It's very simple. It's almost like just using a text editor. And I think that's a good thing, but I suppose if you're a hardcore coder, it might be different for you. So I actually found that there's a couple idiosyncrasies that made it difficult for me to use the RP2040. Not difficult, but I guess it was a little bit more challenging. There was more stuff I had to keep in mind. So because I love the chip and I had problems with it, so I decided I'm probably going to write a script for a video that sort of goes through all the quote-unquote problems with the RP2040 boards for beginners, for people transitioning from Arduino specific boards, especially the Uno, the Mega, the simple Arduino boards into the RP2040. So here's a little bit of my list. And if you've encountered any issues, let me know in the comments below, because I want to add them to that video. I think it'd be really good to get a little bit of community feedback on all this. First thing was the support. So you have to go into your file preferences and then add a URL to the boards manager, to the additional boards. And then you have to go to the boards manager and you have to go into the drop down and install the boards. And so although this is quite simple, it's, a couple of Google searches away. And I really don't begrudge anybody that has issues Googling, because if you're a newbie, newer than me, I would say that you don't necessarily have the right words to know what you're looking for, right? If you read that the RP2040 is supported by the Arduino IDE, then you could be forgiven to think that you can just plug it in and it'll work. But that's not the case. You need the board definitions. So I actually want to put the URL, the literal string that you have to put in. I'm just going to put it in plain text in the description of the video, send people there. I mean, it's much simpler than sending people on a wild goose chase to go find these things. And plus the video should be there, until Google collapses under its own weight. So who knows if the site that hosts that has this info on it will still be there, when my video is still up. So I'm just going to put it in plain text underneath there. And in fact, I actually have to check it out because I use the IDE, like the old one. I use 1.8.19, and the new one I think it's 2.3.4 at the time of this recording. It's completely different. So I do have to check that new one to see if that's still the step you have to take in the new one, or if you have to install the boards at all. Who knows? But that's one thing, is you need to add the support to the IDE. So that's one. Second thing is COM ports. So like I was telling you, I had issues because I couldn't find my board it wouldn't show on the COM port. Well, I guess what happens is you don't need a COM port anymore. The RP2040 shows up as a USB drive, and when you tell the IDE to upload, what it'll do by default is it'll compile it, verify it, and then search your computer for any connected RP2040s in boot mode. So you don't need to select a COM port anymore. And again, I didn't see this in the regular sort of documentation. Like when you look up, how do I add support to it? It doesn't tell you about all this. It's all stuff you kind of have to figure out on your own. And well, that kind of stuff stopped me from using the chips. And so I want to share that knowledge. So the first things first is when you get your RP2040 and it has no program on it, like never been programmed. If you plug it in, it immediately shows up as a USB drive. And at that point, if you hit upload, then your code is going to get compiled, verified, and then uploaded to it. Now you unplug it, you plug it into your breadboard, you test that your code works the way you want, and then maybe you make modifications. When you go and plug it in that second time, after you've programmed it once, it no longer shows up as a USB drive. No problem, you think, I'll just compile and verify the code, and then it'll look for an RP2040, and then it'll upload. Wrong. It doesn't do that. From the second time, from the first time you program it, every time after that, you have to press and hold the boot button as you plug it into your computer until it shows up as a USB drive. So that's not something that I knew. That's something that I spent some time on a live stream trying to figure out, right? So these are things that if I can make a video, 5-minute long video, 10-minute long video to save someone a half hour of frustration, that makes a lot of sense to me. So yeah, every time after the very first time you program it, you have to press and hold the boot button, which is interesting. Also, it's a design consideration. If you put this board into your product or whatever you're making, your gadget, then you have to have that boot button accessible if you ever plan on reprogramming it. If it's totally enclosed in the bowels of a robot, but you left the USB exposed so you can reprogram it, but you can't reach that boot button, you're screwed. So it's a design consideration. Next things up that I've noticed is pin modes. So you don't actually have to set any pin modes on the RP2040 chips. So typically you would go into your setup and declare a pin as an input or an output. But in this case, you don't have to at all. As soon as you call for a digital or analog read, it'll automatically set the pin as a input, and a digital or analog write, it'll set the pin as a output. And so that's really nice. However, what's even nicer than that is if you do want to set your pin as an input, you can then make use of either the built-in pull up resistors or the built-in pull down resistors. That's right. Selectable on any of the GPIO as far as I can tell. is that you can actually use an input pull up or an input pull down just by calling, your regular pin mode with your brackets, pin number, and then input pull up or input pull down. So that gives you a little bit more flexibility in your PCB design or your project design. It also gives you the chance to use sensors and logic that require a pull down resistor without adding a resistor to your board. So that's a really nice feature as well. Next thing up that I didn't see a lot of chatter about, in fact, I had to go a little bit back and forth with ChatGPT because my code wasn't ending up the right way. The RP2040 has a 12-bit ADC, but the way that Arduino seems to handle the analog read function, it only returns a 10-bit value. So I was expecting a 12-bit analog read from a potentiometer, but I only was, I was mapping that onto another value, and I was getting some weird results. I only got like a quarter of the amount that I thought I was going to get. And the reason for that is, there's 2 bits missing. Apparently, it's a problem with the analog read function. And what it does is it takes the 12-bit ADC value from the RP2040 and it converts it to a 10-bit value, and that's what it returns to you, the user. And then so you have to do your work on this 12-bit value. It's not written anywhere like clearly, in big letters, all in bold or anything like that. So it's kind of something that I discovered by experimentation. Also, I took a look, and there doesn't seem to be a very easy way to access the 12-bit values of the ADC using the Arduino IDE. I mean, it is doable, but it's quite beyond my comprehension for the moment. I might look into it in the near future, but it seems like you'd have to read the memory registers directly from the RP2040 instead of using the analog read function. So something to keep in mind, and that caught me out. That was another big delay in my prototyping, is that I didn't realize this, so I need people to know this as well. Now, if we keep all this in mind, the RP2040 is still a great candidate for a chip. It's still amazing. There's other stuff that I want to get into because there is a state machine built in, apparently. So I want to be able to mess with that a little bit in the future. Essentially, what I'm saying is that if you are intending on following my channel and sort of recreating the projects that I do here on my channel, it's probably best to order a couple RP2040 boards. The RP2040 being my favorite at the moment, but the regular Pi Pico board should work just fine too, because I have a couple of those and a couple of compatible boards, like Pi Pico compatible, pin compatible boards that are a little bit better. So yeah, if you want to check that out, it's probably a good time to order them if you're intending on, recreating some of the projects that I do here over where you are. So then, on the subject of the RP2040, which happens to be my favorite at the moment, I actually designed 2 PCBs for the RP2040. Let me try to explain what the problem with it is. So it doesn't fit in a breadboard. So if you picture the RP2040 as like a sort of like, it's a rectangle, but it's quite square. So it's almost a square. It has 2 parallel lines of pins, one on either side, but then it has, I think it's 6 pins that go perpendicular across the bottom. It's a very small board, and to get all the pins from the RP2040 out to pins is kind of difficult. On top of that, of those perpendicular pins that make it incompatible with a breadboard, there's also 10 pads on the underside. And when I say pads is generous. These things are tiny. They are probably the physical size of the tip of a pin header pin, but there's 10 pads underneath, and they have 9 more GPIOs. So you can access all of the GPIO of the chip on this board, but not easily. It's much easier to access all the GPIO except for that 9. So in order to make projects, I need to prototype it on a breadboard. I mean, I'm not super familiar with the way it works, so I definitely need to prototype up stuff first and then design the PCB once the design is finalized. So I need a way to adapt it to a breadboard, and that's what I did. I actually designed 2 PCBs. So one I call the Micro and one I call the Mega. And let me tell you, these PCBs were the most difficult to route tracks that I've never had that much difficulty routing tracks in my life. So the RP2040 is tiny, right? It's like postage stamp sized. And because of the row of perpendicular pins, there's only room to route a single trace between 2 pins. Like, it is absolutely tiny. It's 0.1 inch pin spacing. And so you can only really fit 1 track, maybe 2 if you push your design rules a little bit. And so to link all of those pins, plus I linked the 9 pads on the back. There's 10 pads, but one is an additional ground. So I didn't feel the need to route that one. But to route 9 pins from the middle of the board, through to a set of 2 parallel pins that fit into a breadboard and allow you to breadboard. Like, maybe I'm not explaining this right, but your RP2040 will be hanging off the edge of your breadboard, and then you'll have like a dual inline package sort of pin spacing, rows of pins that you could plug into your breadboard. So I routed every single one of the pins out to a breadboardable 2 rows of pins, including the 9 pads. Now, the 9 pads, I will warn you, they are not practical to use, because in order for them to be used on breadboard, you're going to have to solder a wire onto the pad and then onto my adapter PCB. So it kind of like traps your RP2040 there forever. But if you wanted to make a project that needed all of the GPIOs, or needed a couple additional GPIOs that are only available on those pads, you would have to do that on your project anyway. So it is real, right? That is actually how you would have to use that. So I picture, you put the pin headers in so you can drop your Micro into your PCB. And then I think you would solder the 9 pads onto like a really small connector. Like you'd have a length of wire, and you'd have something like a Pico blade, like a Molex Pico blade 9-pin connector. And then you'd have, the corresponding connector on your project. So you could solder a 9-pin Pico blade connector onto my adapter board if you want. But I think in general, for the video where I will release this project, I'm going to tell people, look, I designed this so that if you want to use the additional pins, go ahead and use them. But if your project really needs those additional pins, I would recommend that you just use an RP2040 in the Pi Pico form factor instead of the RP2040, because it's a bit ridiculous. I mean, you'll see in the video, but the pads are ridiculously small. So yeah, you'll understand. Trust me, you'll get it. However, I do think the Micro board that I made, which doesn't include those 9 additional pads in the middle of the footprint, I think those are going to be really useful, because again, you'll have plenty of GPIO for almost any project. Pretty much any Arduino Uno project would have enough pins with the RP2040, because the RP2040 has more GPIO than an Uno does. So in that case, you can really get your projects really small, and hopefully you'll like my PCB for prototyping it. I also found that there is actually an adapter PCB that you can get, but if you needed more than like 2 or 3, I believe buying my adapter from PCBWay is actually going to be cheaper than buying those. There's one listing for a prototyping board that accepts the RP2040. So I think my PCB design will actually be a more economical solution than ordering adapter boards from AliExpress, simply because those adapter boards aren't very common. And who knows, because my PCBs are all open source, maybe some AliExpress seller will start selling my designs. I mean, there's only one way to find out, right? Is to make it, and maybe they'll come. So yeah, that's two PCBs that I designed right there. Now a third PCB that I designed, and all these PCBs should be coming in on Wednesday, the 12th, February 12th. So maybe by this weekend's live stream, if you're around, probably on Sunday morning Eastern time, I'll probably be putting them together and making sure they work and getting them ready for making a video. And maybe we'll even make the video on that time. So the third one is a servo tester. So if you have worked in any kind of like hobby robotics, or if you've done work with RC cars, RC vehicles, then you know what a servo is. But for those of you who don't, it's essentially a motor with a gear train and positional feedback like a potentiometer, but all built into one case. Usually a square, like a rectangle case with standard mounting holes and stuff. And there is like usually one axle, like one axis that pokes out from one of the sides of the servo. And that axis usually rotates like 90 degrees or 180 degrees, or sometimes 270 and sometimes 360 and sometimes continuously. But I think the most common is 180 degrees. And that servo requires power, it requires ground, and for its control, it looks at the length of a pulse. Now, I could be wrong about this, but it sends out a pulse, or it reads for a pulse about every 20 milliseconds. It expects a pulse, I should say. And I think the pulse width is, I think it's like 1 millisecond to 2 milliseconds. So I think 1 millisecond would be all the way over on one end, and 2 milliseconds would be all the way over on the other. So if you have a 180 degree servo, 1 millisecond would be sort of like 180 degrees on one side, and then 2 milliseconds would be 180 degrees on the other side, and 1.5 milliseconds would be like the center position. And that becomes important for what this project does. So when you first unbox your servo, you need to attach like an arm, or something, because something that it will go control from its axis. Typically that arm is splined, and typically you get a whole bunch of arms as accessories in the box with your servo. We call them servo horns in the RC hobby, but I'm not sure if the electronics or robotics hobby calls it something different. But regardless, you have to attach the servo arm on the servo clocked at a certain position, because if you only have 180 degrees of rotation, you need to, position your arm in the angle at which you're going to be using it, between 0 and 180. But if you want it between 180 and 360, you put it on the other side. But when you first unbox your servo, you don't know at what position that arm is. Did the factory center it for you? Did the factory test it and just unplug it from their test jig wherever, at whatever angle? If you just give that servo its power and ground, it jams, it freezes, it stays right there until it gets a signal. And so usually what you would have is a servo tester. It's a little device you can get on AliExpress. Back in the day, you used to be able to buy them for like $1. Pretty sure now they're like $5. But they're not very expensive. They're very small. And what they do typically is they have 3 modes. One mode will send a 1.5 millisecond pulse to center the servo. Another mode would sweep the servo from one end to the other. And another mode would allow you to turn a pot to position the servo. So what I decided to do as my first RP2040 project, because there's a servo library over on the Arduino IDE, is that I wanted to make a little servo tester for a couple of reasons. One, I can never find my servo tester when I need it. They're really tiny devices. And 2 is because I don't think that if someone gets a servo in like a kit, right, like one of those all-in-one Arduino Uno kits or whatever, it doesn't matter. A robotics kit, it doesn't matter. I don't think they should have to order a servo tester from Amazon, which will be like an order of magnitude more expensive than AliExpress, or wait a month and get it from AliExpress. I mean, there's libraries available, so why not just breadboard up a little microcontroller, upload some code, and then that's your servo tester that day. Just a quick interruption to talk about today's sponsor, PCBWay. Your awesome circuits deserve to be immortalized in a PCBWay PCB, and the best part about it is incredibly cheap. You can get up to 10 boards, 10 centimeters by 10 centimeters for $5 plus shipping. You can choose the rapid shipping if you really want it quickly, or you can choose economical shipping if you don't mind waiting and want to save some money. Not into electronics? No problem. PCBWay also does 3D printing, CNC work, and sheet metal work. And on top of that, their processes are way cheaper than buying the machines for yourself. Just go price out a 3D print. You'd be surprised how cheap it can be. But the number one reason to go check out PCBWay is because they support makers. They've been supporting this channel for several years now, and they've supported small channels and big channels alike. They just want to be part of the maker movement. So check out the link in the description, and if you get something, it supports channels like mine. Back to the show. So I designed a servo tester with the RP2040 chip in mind, but I added, because I built a PCB for this, I added a whole bunch of features. So the first thing is that I also have 3 modes like a traditional servo tester. So when you start the thing up, it starts in mode 1, which centers the servo. That's probably the most utilitarian thing to do to a servo, is to have it centered so you can install your servo horn on it at a neutral position and you're good to go. So it takes 5 volts in either from screw terminals or from the USB-C cable, and it powers up the servo, centers your horn, and you're good to go. But I also have a push button and an LED. The LED indicates what mode it's in. So you push the button, it switches to mode 2, and in mode 2, it'll sweep the servo from one end of its range to another. So it sends a pulse width, a 1 millisecond pulse width, and it gradually increases to a 2 millisecond pulse width and back down to 1 millisecond. So it'll sweep from one end to the other. So you push the button again, and then mode 3 LED comes on, telling you what mode you're in. And then it reads a potentiometer input, and then you can put the servo in whatever position you want. Or if you just want to do manual control of a servo, that's a great way to do it. And again, because the RP2040 is so small, this PCB ends up being kind of small. I mean, it's not as small as the commercial ones, but in my case, it's a bit of a bonus because I won't lose it type thing. But I also added a couple more things. I actually added 2 more LEDs. And then so if you want to order the PCB or make the project yourself, you can code in mode 4 and 5 if you really want to. So you can have it do whatever you want in mode 4 and whatever you want in mode 5. I left room for expansion. If you want to hack my thing, it's a lot less difficult. You don't have to redesign a PCB. It's already on there. And if you don't want to waste LEDs or whatever, just don't put them on the board. It's that simple. The other thing I added is that most servos are 5 volt, but not all of them. The common ones are 5 volt, but some of them are like really small and they run on like 3.5 volt or 3.3 volt. Some of them are really big. They can run at like 7.5 volts to go faster, or 8.4 volts. 9 volts is another common one, and 12 volts I've seen. There may be even 24 volt ones. I don't know about that. So what I did is I routed the signal for the servos to the signal pads on the PCB, but I have another set of pads that also receive the signal that are connected to ground but are not connected to the 5 volts. That pad is actually routed to a screw terminal, so you can put in whatever voltage you want and feed your servos that voltage with that set of pads. So if you need to center a 12 volt servo, which I do have some here, then you can hook up a 12 volt power supply as well as a 5 volt power supply for the RP2040, and away you go. You can now control your 12 volt servo without a mess of wires, right? You don't have to like split up your wires and stuff. So I decided to build one so that If you have a board kicking around, you can just breadboard your own kind of thing. And on top of that, I'm very proud of my code. I wrote 100% of my code here in my workshop. I did use ChatGPT, but not for the code. It was more for like the rubber ducky aspect. So I was asking it syntax things, and I was going like, okay, is this the proper way to use this? Like, for example, when I need to increment a value, I was like, value 1 equals value 1 plus plus. And I was like, is this correct? And it said, well, you can just do value 1 plus plus, those kinds of things. So I'm pretty happy with my code, so much so that I'm going to obviously release the code open source as well. Should be making a website article for this also, because I think it's pretty cool. And the other thing I want to release is the footprint for the RP2040 So if you want to go into your KiCad and use my footprint, you should be able to just import it and then make your own PCBs based on the RP2040. Next up, we've got some Unity news. This is a bit weird, but anyways, I have 3 Unity videos that are filmed and are in the editing queue. One of which I was supposed to do for quite a while, and I'm going to stall a little bit until I get the part number of this thing. There we go, the UTG 1042X. This is a signal generator that was sent to me by Unity for review. Actually, they sent it as a gift, and then they said, we would love to see it in a video, aka hint, hint, wink, wink, please make a review video. But I was really struggling on this one for quite a while. And the reason for that is they also sent me the UTG 962E, which is another function generator, which is much smaller and $100 cheaper. And I was struggling to see the value in the 1042X. You see, I'm like a hobbyist. I'm a beginner. I am really not that qualified. Like, if I sent this to an engineer, they would know immediately the differences. But for me, I was having a hard time finding anything that was positive enough on the UTG 1042X to recommend it on top of the UTG 962E. Because I love the 962E, and the interface is the same. The 962E has a 60 megahertz bandwidth, whereas the 1042X has a 40 megahertz bandwidth. And so, like, on paper, if you're just looking at it at surface level, it seems like you should just get the cheaper one. But the big difference, now I've finally drilled down into all of the stuff that makes it different. The big difference is that the 962E, the small one, the cheaper one, is 14-bit. And the 1042X, that one is 16-bit. And that makes a world of difference. I was just doing some research real quick, and a good quality 16-bit ADC can easily be multiple times more expensive than a good quality 14-bit ADC. So that is probably one of the reasons for the cost increase. But the other thing too is that it does a little bit better. It does more modulation styles. So if you really need those modulation styles, then you need to get the 1042X. And the other big deal about it is it comes with a certificate of calibration, which has been done on traceably calibrated test gear, calibration gear. So if you work in an industry, or maybe if you work in a startup or a small company, small boutique manufacturer, and your stuff interfaces with stuff that requires, a certain level of accuracy and traceability, already to take your traceably calibrated device over to a calibration house and get it calibrated is more than $100, as far as I know. So just the certificate could be worth that $100 difference. But the fact that you get 2 extra bits, which translate to 4 times more discrete vertical steps, in representing an analog wave with a digital signal, that's why it's more expensive. And I believe my video goes far enough to explain that if you at home are browsing the Unity catalog and you see these two function gens and you quickly look at the specs and you're like, wow, they're charging way too much for the 1042X. The 962E is a way better unit and it's $100 cheaper. If that's you, I agree with you. Go buy the 962E. I actually love that thing. Whenever I need a function gen, that's what I turn to. However, if you look at the specs and you're like, wow, I really need a 16-bit or I really need a calibrated device, then you have to get the 1042X. And compared to, similar competitors like from Sigalint and Keysight and stuff like that, really the 1042X is a bargain. Unity tools happen to be in a really good price to performance ratio area. So I believe my video goes far enough to explain these kinds of things and to explain why, if you need the 1042X, you have to order the 1042X. And if you don't know if you need it, then you should just buy the cheaper one. That's always been my opinion on this channel, is that you don't need expensive gear. And truly, if you don't have a real reason to get the 1042X, just get the cheaper one. I mean, it's that simple. I also ordered 2 other tools from Unity, from AliExpress this time, not from the US distributor that sent me the test gear. But one thing is a sound meter. So I'd never actually owned a sound meter. And in fact, I have a couple devices that have quite a loud fan. And I was like, okay, I want to upgrade the fans, like let's say in my 3D printers, for example. So I want to upgrade the fan and I want to show people at home the difference it makes in having a quieter fan. But it's really hard to quantify that, especially since I run a lot of my audio tracks through noise reduction and stuff like that. So it's not easy to quantify the difference in sound levels. And also, it's not easy to quantify how much noise is in this room I record. I mean, I'm sitting, I think it's 42 decibels sound floor when I tested it. So anyways, I got a sound meter, and when I was shopping on AliExpress, I was like, do I get an 18 Canadian dollar sound meter, which has no brand, no loyalty? It's all the same, right? Everyone's selling the same one with no brand on it. Or do I spend a little bit more? And I think it was $28 for the Unity one, $28 or maybe $30, something like that for the Unity one. And I was like, well, that's a no-brainer, because I know that the Unity one will at least meet a minimum standard of quality, even if it's the Chinese line. So I went with the Unity one. Tools are one of those things that you don't really turn them over a lot. And so I figured for a little bit more, we're only talking like $12 or something like that difference, I would just get that. So I did order that and I gave it a test, and it's actually, I like it. I mean, it does what it says on the tin. But then I also saw they were selling light level meters. And I was like, oh, that's interesting, because I have flashlights. I order LEDs. I make projects with lights. I might as well pick one of those up too. So that was another $30 for the Unity one. Again, I could have got a cheaper one, like $12 or something for a cheap one. But can I rely on the readings from some, where a company won't even go as far as put their own name brand on it? If they won't trust their own product to a name brand, then how can I trust its readings, right? If I just needed it once and I just needed to know the relative of something, whatever, I could have probably bought the cheap one. But if I'm making a video and I'm saying, this X brand light says it outputs whatever, but my light meter says it outputs whatever minus whatever, then I need to be able to at least semi-confidently say these numbers are accurate. I need to be able to stand behind my statements. So that's why I bought a Unity light level meter, and we had to play with it on stream. It was pretty nice. Actually, we had to play with all those things on stream. And I was like, oh, let's get flashlights and stuff, because I have flashlights that claim to go really, really bright. Because of the inverse square law, the further away from the sensor you get, you lose brightness at like a 4x rate or whatever. But I had shielded this from the ambient light with like a filament box, and my second flashlight overwhelmed it. So it was like maxed out. So I'm going to have to figure out some sort of, I'll probably like print a black tube or something and have like nozzles at the end. So it would fit my meter perfectly in the tube, and it would have like a nozzle that would cradle my flashlight at a precise distance, and then we can shoot out the flashlight. So that would be pretty nice. So that's a plan. But that, that kind of thing, which requires a lot of 3D design, that's like down the road thinking. That's not like right now thinking. For right now, I've got way higher priorities, but that's one of the things that I want to do. So those 3 videos should be coming out, within the next couple of weeks. Give me some time to edit here, folks. Well, what else did I have to talk about? Well, there was one thing that I was thinking too. When I was testing the RP2040 servo tester, it just wouldn't work for me. And I mean, the reason became incredibly stupid, so I don't even want to share it here. But when I was looking up, like I thought maybe the 3.3 volt logic wasn't enough. It wasn't high enough voltage to trigger the electronics in the servo. So I figured, maybe that's it. So let me go look on YouTube for other creators that have controlled servos with Raspberry Pi Pico, which has 3.3 volt logic, or a Raspberry Pi, because it also has 3.3 volt logic. And I want to see what they use for level shifting or whatever, so I can get myself ready to, to install that in between. And I searched YouTube for what I was looking for, servo with a Raspberry Pi, either a Pico or a Pi. And I found 2 creators. I think one had, I don't remember their names now, but it's inconsequential for my point here. One had over 30,000 subscribers, and the other one had over 100,000 subscribers, if I'm remembering correctly. And these were 2 creators that are in the electronics niche. They do electronics videos, very similar to stuff that I do. And I had simply never heard of them before. They did not pop up on any of my socials, Instagram, Blue Sky, and all the times that I went looking for stuff on YouTube, they weren't anywhere to be seen. They have relatively old channels. They just weren't anywhere. And then, well, I guess I subscribe to them because I want to keep in touch with them. They make good content. But that reminds me that the YouTube algorithm is horrible. It doesn't give me what I want. Can you believe someone who runs the Simple Electronics podcast that literally searches YouTube for new electronics creators, makers, and all sorts of people to invite onto the podcast? That kind of person with that kind of search pattern wouldn't get recommended new electronics channels. That is complete nonsense. So that kind of made my blood boil. And then I talked about it on the live stream, and the people, the chatters in my live stream, they all agreed. The algorithm is horrible, especially for like such a small niche like ours, electronics. It is horrible that electronics creators cannot find each other, even if we watch electronics videos, simply because the algorithm hasn't matched us up with, a video from that creator yet. So that doesn't make any sense. So I thought I should start a community service. So I know if my wife is listening to this, she's going to say, you don't have time. You shouldn't take on more work, especially with zero payoff. But this is something that I'm passionate about. So what I am thinking of doing is I'm going to use the electronics creators that I already know, that I already have on the podcast, that I already found through YouTube. And essentially, I want to make like a 1-minute video or less, like a 30-second to 1-minute video telling people, about the channel. I want to just do a quick snippet of why I like this channel, why the channel is good, what are the positive aspects of the channel, and then maybe point people to 1 or 2 videos with a quick summary. That's it. That's all the video will be. Just here is this creator that you've probably never heard of. You should check out their channel because of this. If you're looking for videos to try this video because of this, or this video because of this. That's it. Very short, one take, not using my camera, just using my web browser and OBS to capture the channel. And then I'm going to take that information. So the person's, the channel's name, a quick description of them, maybe a couple tags and their channel links, and put them all in a table on my website. So the goal would be to eventually, like I won't be able to do 100 of these a week, mind you, but the goal will be to eventually have a little bit of a database of people who make electronics videos. I would love to expand that to makers in general, maybe on 3D printing niche, on the CNC niche, like just makers. But for now, we're going to start with electronics because the algorithm doesn't seem to favor, component level electronics or electronic project makers that don't make massive projects like I turned this resistor into a boat and then crossed the English Channel with it type thing. So I believe this is something that I can do with relatively minimal input on my end. And once I've got about 20 of them made, of these videos, which I don't know what channel I'll put them on. That's inconsequential. I'll deal with that when the time comes. But once I get about 20 of them made, what I'm going to do is I'm going to open it up to everyone else. So people can either submit their own channels or they can submit channels that they watch. They'll just fill out a Google form and it'll all I'll collect all the responses, and maybe once a week I'll knock out like 5 of those videos and add them to the database. 5 of those videos, add them to the database. It's going to be slow going, but over time, it can be something really cool. And on top of that, I think right now, especially with the algorithms changing all the time and uncertainty all over the industry, it'd be a really good service to help electronics creators find each other. Like even if it's just a link, it doesn't have to be emails or whatever. It's just a link. If the creators wanted to get all together and make a Discord or something, that's fine too. That's totally fine. I'm not doing that. What I want is a public register of electronics focused creators and probably in the future maker focused creators. In order to when someone goes like, hey, where are all the other channels like yours? You can point them all to this chart, and then the person can go and subscribe to all of them if they want to, that kind of thing. So this is one of those places where I really want to know what you think about that, because obviously it's going to start with me kind of hammering down the format that I'm comfortable making. But then it's going to also come down to what you guys think is good for the community. I am not a fan of locking all this information behind Discord, simply because you can't Google search it. It'll never be searchable from the outside. And I think if I maintain a table, a chart on my website, publicly accessible, and I make a video about it, and maybe creators can talk about it themselves, whatever. I'm not asking for any advertisement. At least then it's Google searchable, probably AI searchable for, better or for worse. And then people that are not in the inner circle, that are not in the know, that do not have the Discord invite link, can find creators. They can find people that make cool stuff and put it on the internet. So I've seen a lot of people with way better electronic skills than me, and they have way fewer subscribers than me. And, it's just not fair. So that's the goal. I'm going to make a database that will be searchable. You can Control F, or maybe eventually there'll be tags that you can, you can search for and stuff like that. But essentially, that's the deal. I want to make a database where electronics creators can find each other and electronics enthusiasts can find creators to follow. So what do you think of that? Let me know in the description. Well, I guess this will be it for today. I want to thank you all for being here. It is now 10:27 p.m. on the day before this is supposed to go to early access, which means it is like an hour and a half away from my birthday. And all I want for my birthday is you guys to keep watching. Don't worry about anything else. I mean, if you feel like supporting, don't do it because it's my birthday. I just want you guys to keep watching, keep enjoying the content. And if it wouldn't bother you, leave a comment. Let me know if you like podcasts like this or what it can change or what's your opinion. Just talk to me. This is the best part of YouTube, is the back and forth. Thanks for listening, everyone. I'll catch you in the next one.